Hi guys, so today I'm going to try and keep this nice and short. We're looking at section 3.1, solving linear systems by graphing. So we'll be using your graphing calculator a lot. Make sure you have this out. Any case, so our objectives today are find a solution to a linear system by graphing and graphically determine if a system has one, infinitely many, or no solutions. We'll look at what that looks like on a calculator. Okay, so system of equations, you're all aware of what that is. I don't really have to explain that. And a solution is an ordered pair. Just remember that. A solution to a system is an ordered pair. Okay? Alright, so let's go through and use your calculator to solve some of these. Alright, now graphically a solution to a system is a point where two lines intersect. Problem is I can't graph this in my graphing calculator. It's in the wrong format. I first need to put it in slope-intercept form before I can graph it. If you look at your calculator, when you say y equals, it's looking for y equals, okay, to graph. So I need to put functions in slope-intercept form. So let's do that first. So what we do here is take each equation and put it in slope-intercept form. I'm going to write this one over here and then put it in slope-intercept form. So take away the 3x, okay, and then divide by 2. So this equation is negative 3 over 2x minus 2. And this equation over here, if we solve this one for y, we get this. Divide by 3 both sides. So you basically get negative 1/3 x plus 1/3. Okay? So these are the two equations we're going to graph. These are the two equations. Let me just put them in a box here. These two equations, we're going to graph these two. Okay, so go to your calculator and let's do that. So on your calculator, you're going y equals negative is down here, okay, and then 1/3, I would put it in parentheses if I were you, otherwise your calculator is getting confused. X plus 1/3. You don't really have to put the back fraction in parentheses, but I'm doing it in any case. It's better to add parentheses and make sure that your calculator knows what you mean. Otherwise, you might make mistakes. And then the next one is negative 3 over 2 x minus 2. Okay? So these two equations, enter them in, and then graph them. Just hit graph. And now I'm on some kind of an extreme zoom here, so I might have to zoom out to show you the full effect here. So let's go to zoom, and let's just do zoom standard. Okay, so you can actually hit 6 zoom standard. So this is the standard window, 10 by 10. And so you can see the point of intersection is here. That's the solution to the system where the two lines intersect. But you can find that. You just go second and calc right there, okay, second calc, and intersect is number 5, okay, and then it asks you questions. The first curve, or the first, in this case it's a line, the first line, yes, is that one. The second one, it's dash flashing on there, yes, that's the second one. Do you want to guess? No, I want you to do it, calculator. And then you find the point of intersection is negative 2, 1, okay, so that's the solution of the system. It's negative 2, 1. Solving it in your calculator, okay, graphically, this is it, where the two lines intersect. That's solving it graphically. Alright, let's do one more. These are all kind of similar. Let's just do number 2. Okay, let's just do letter B here. So again, solve each equation for y. I can't graph it like this, okay. Solve each equation for y. And let me get back out here and clear these out, okay, so we can enter them into our calculator. Alright, so let's do that. So let me take this one and write it over here again. 4x minus 5y equals negative 10. And solve this for y. So take away the 4x. So negative 5y equals negative 4x minus 10. And then divide everything by negative 5. Alright. And I know you're a master of this stuff already, so that's not something I'm really going to take very slowly here. And this would be plus 2. Okay? And next one, solve this for y. So negative 7y equals negative 2x plus 4, divide by negative 7, so you get what? 2 over 7x minus 4 over 7, okay? This is not a pretty equation, but it still works, all right? So I'm going to try and graph, not try, I will graph these two things, okay? And then see where they intersect. That's the solution. That's the solution, okay? So let's enter this in the calculator. So again, use parentheses, 2 over 7 times x minus 4 over 7. I just like to use parentheses to be safe, okay? And then this one, same idea, parentheses, 4 over 5 x plus 2. All right, enter, graph that, see quickly where do they intersect. Back here somewhere. We don't have to guess or trace, we can just say second calc and then do intersect 5. Okay, first curve that one, yes. Second curve's that one, yes. I don't want to guess, tell me the answer. And so the answer is negative 5, negative 2. Okay, negative 5, negative 2. This is kind of ugly. We'll look at this on some software in class, but you get the idea. I can still find the answer for you. All right, so let's go ahead and move on, and let's talk about classifying systems. So let me clear this out again. We're going to do more of this graphing on your calculator. Okay, so classifying systems. So a system that has at least one solution is consistent, okay? And if a system has no solution, it's inconsistent. So this is just vocab that you have to know. You have to know this vocab, important. A consistent system that has only one solution is independent, and a consistent system that has infinitely many solutions is dependent. Okay? So these are the three scenarios you have here. They have the vocab there that matches the graph. So we're talking about graphically solving systems today. So we're looking at the graphs, all right? So this is what it looks like on a graph when there's only one solution. We just saw that. Now, it doesn't have to be perpendicular, just any two lines that intersect has one solution. That was all the examples we just did. Infinitely many solutions look like this when you graph it, because actually you're graphing the same equation twice, okay? So it's overlapping itself, and so this is called infinitely many solutions when it looks like this. And no solution is when you have parallel lines. So if you can look at two equations and see their slopes are the same, which is reviewed from before, then you know that these two lines are parallel, so they have no solution. Then they're not going to intersect each other ever, so there's going to be no solution. Okay, vocab you have to use here. This is one solution only, so it's consistent and independent. Infinitely many solutions, consistent and dependent. No solutions, just plain old inconsistent. Okay, so you need to know the vocab to classify systems. All right, so classify the system. Here's the vocab, classify. All right, so let's go and just do this same exact thing that we just did. I think what we'll do is do the first three. Okay, let's just quickly go through the first three and see if we can get through that very quickly. So if you look at this, solve each one for y. So basically what you get here, the first one, let me do the first one down here, is negative 2y equals negative 3x plus 10. Divide by negative 2 here. Okay, so what you get is y equals 3 over 2x minus 5. All right, this one, let me put a different arrow down here. If we solve this one, you get negative 2y equals negative 3x plus 2. And if we divide this by negative 2 everywhere, you get y equals 3 over 2x minus 1. Okay, now I just said if the two lines are parallel, then they have no solution. We saw that up there in the little box. Now these two lines have the same slope, so I don't actually have to graph this. I know that they have no solution. But the point of this lesson is to figure that out graphically. Okay, so let's go ahead and do that over here. let's graph them. So the first one again, parentheses 3 over 2 x minus 5, and in the second one 3 over 2 x minus 1. Okay, please show up x minus 1. Okay, this thing is unresponsive. Great. And then say graph, and you'll see what happens. Two parallel lines, no intersection. Okay, and so the answer for this is no solution, and to classify this is inconsistent. Okay, it's an inconsistent system. All right, inconsistent. Okay, so that's no solution. Classifying means inconsistent. All right, so solving and classifying. All right, let's do one more here, or let's do two more actually. So here, same idea. Take the first equation, solve it for y. So 5y equals negative 2x plus 6. Divide by 5, y equals negative 2/5 x plus 6/5. Okay, a little bit of a strange equation there, not nice and tidy. This one, let's solve that for y. 10y equals negative 4x plus 12. Divide by 10 both sides. If you divide this by 10, you end up with negative 2 over 5x plus 12 over 10 is also 6 over 5. Okay, and so look at this. Now you have an interesting situation. Here's one equation, and here's the other. Okay, now what do you see? They're exactly the same thing. So we just said if you have two equations that are exactly the same, when you graph them, you're going to get one graph. Okay, so I'm not going to go and graph the same thing twice. Basically, graphically, it's going to look like this. All right, you're going to have negative 2 over 5 x plus 6 over 5. Enter that. This is what it looks like. It's one line. They're both exactly the same thing. Why would you graph that twice? Okay, so it's one line. So when this happens, you know that you have infinitely many solutions. Okay, infinitely many solutions. And to classify this, this is called consistent and dependent. Okay, consistent and dependent. Okay, all right, so that's that one. All right, and now let's do one last one to show you the third option, which is consistent and independent, and that's this one right here. So this one a little bit easier. Let's solve the first equation for y. Y equals 2x plus 5, and the second equation is already in slope-intercept form. Yay, less work. Okay, and so let's take this. Let's clear this out. Let's graph it and see what happens. So I'm graphing this one, y equals 2x plus 5, and I'm graphing this one, y equals negative x plus 2. Okay, graph that. Two equations. Let's see what happens. Oh, they intersect. So I have a solution. So I say second calc. Find the intersection 5. First curve, yes, that's fine. Second curve, yes, that's fine. I don't want to guess. Tell me the answer. And there it is. Okay, so negative 1 and 3. That's the solution to the system. Now, what do we call that? Classifying it is consistent. Okay, consistent, and it's independent. Okay, independent. Okay, independent, consistent, independent. All right, so we've seen all three kinds. All right, okay, so last two here. Let's just do one. I'll do example 3. If you want to look at all the other solutions, it's online. I posted it in the completed notes section. Okay, but let's just do one, and I'll do example 3. Okay. So let's work on example 3. Okay, so let me take this out again. All right, and let's work on this. It says you ride an express bus from the center of town to your street. You have two payment options. Option A is buy a monthly pass and pay $1 per ride. Option B is pay $2.50 per ride. monthly pass costs 30. After how many rides will the total cost of the two options be the same? Okay, so you've got two things going on. You've got an option A and option B. Okay, and so let's write an equation for each option. All right. So option A says you're riding the bus and you can buy a monthly pass and pay $1 per ride. Okay, so my cost for option A would be $1 plus the monthly pass fee. Okay, so what I do there is say, okay, let Y be my cost of riding the bus. Okay, that's going to be equals to my cost per ride. All right, cost per ride plus the monthly pass price. Okay, this is option A. So Y is my cost. Let's say number of rides variable is X, and cost per ride is $1 times the rides. Okay, so $1 X, 1 times X. Right, $1 per ride. Plus the monthly pass, they say costs 30 bucks. Okay, so this is my equation for option A. Then do option B. Is a different equation. It's simpler, actually. It's the cost, let's call it Y again, is equals to the cost per ride. Okay, it's still cost per ride. Cost per ride. Okay, but there's no other fee. There's no monthly pass. That's it. Option B is $2.50 per ride. Done. Okay, so Y equals cost per ride is $2.50 per ride, which means 250 times X. Rides are X. Number of rides is X. Okay, so basically this gives me my equation. Two equations which make a system, and I can just graph that again and get my answer. Okay, so let's just write this out a little bit neater. Y equals basically 1x plus 30. That's my first equation. Second equation, y equals 2.5 or 250x. That's it. This is my system. All right. So the question is, after how many rides will the total cost be the same? Okay. So when will the y's be the same? All right. So basically, when will these two equations be equal? Which means, when will they intersect graphically? All right. So when will the two equations intersect? Which means the y values are the same and the x values are the same. The cost is the same and the number of rides are the same. Okay. And so all we have to do is graph that again. You just put this in your calculator and graph it, and that gives you the solution to the system when they're equal. And so let's just graph that. That's basically x plus 30. First equation, second equation, 2.5x. Boom. Graph that. And let's see what happens. Okay. That must be my second equation. First equation is nowhere to be found because the y-intercept here is 30. Okay. So what you want to do is zoom out quite a bit. So let's say zoom out, and they're asking where do I want to zoom out. I want to zoom out all the way up here somewhere. So let's zoom out. Come on, baby, do this. Enter. Okay. Ooh, there I see my second equation. So first equation, actually second equation, first equation with a y-intercept of 30. All right. So I'm not really seeing exactly what I want to see there, because I don't really know if that is the intersection I'm looking at up there. So let's do that again. Let's zoom out again, just to be sure. And yes, zoom out there. See what happens now. Okay, so there's my function. Now I see the intersection clearly. And so now what I can do is just say second calc, find the intersection. 5. So nice and elegant. First curve, second curve, guess, no. Intersection is there. And so what I have here is when x is 20, y is 50. Now they're not asking for the cost. They're saying after how many rides will the cost be the same. So both of these lines, y is 50 when x is 20. For both of these options, the cost will be $50 when I have taken 20 rides. Remember, X and Y. X is the number of rides. Okay? So the number of rides is 20. After how many rides? After 20 rides. Okay? The cost will be the same. Alright guys, I'll stop there. That's it. That's the lesson. Not much more to it than that. We'll do a little bit of the graphing in class together, but I'm sure you know this stuff. It's just review. Have a nice day, guys.